solving polynomials. Okay, we're just talking about solving polynomials, okay? Of course, put your name, the date, name, date, period, period 2, and the class. Math 3 honors. This is the easy class. Okay. I know some of you might think it's difficult, and I'm hoping, honestly, I'm hoping you guys are learning in this class. That's my main thing for you guys. Okay, so hopefully you feel like this is easy, but I'm learning. That's actually my goal. I'm just thinking out loud. My goal is to just make you think like I'm learning, but I'm not as stressed. That's my goal. Low stress learning. But hopefully it's not too easy, honestly, but that's me thinking out loud. We can talk about that another time because I feel like I've talked too much about it. Okay. Solving polynomials. Let's say we have a polynomial. Let's see, how do I describe this? Y equals x squared plus 6x plus 5, okay? And we cannot solve this right now. It is not solvable. This is not solvable. Why? Because we have two variables. We have an x and a y. We can plug in many x's and get many different y's. Usually when we solve polynomials, you have to set it equal to 0, okay? So that's the first step. You got to set it equal to 0. Set equal. Now this is an easier one. To 0. You want to set it equal to 0. So I'm going to write it like this, because I usually like the x on the left. X squared plus 6x plus 5 equals 0. Okay, there. Now I can solve this. When y equals 0, that's generally when we solve polynomials. We have to set it equal to 0. Now there's a couple different ways we can solve this. Okay. Let's see. Does anyone know what is one way we can solve this? Someone give me a way. Anyone have any idea? Let's see. Let's go with Virginia. Give me one way. How do we solve this? Just off the top of your head, how would you solve this? If you know a technique, Virginia.
I'm not sure.
Okay, really? There's like 3 different ways.
Oh,
Okay.
you can do the X or the box thing, right?
Yes. Yes, we can factor it. Very good. And there's another way to solve it. Virginia, very good. Ishi, what's another way we can solve this?
I don't know.
Who'd you have for math last year?
Krieger.
Did you guys run around the campus singing a song? Annoying my class?
The quadratic formula?
Yes, the quadratic formula can solve it. That's what the quadratic formula does. So let's go with now I don't need Xbox parentheses. It's called factoring. I just do Xbox parentheses. Remember I showed you a different way to solve it doing grouping, but you can do 5 and 6. What times what equals 5 and adds to 6? It's 1 and 5, right? And so we say this becomes x plus 1 times x plus 5 equals 0. I'm going real basic here, right? Now that I've solved that, what is my answer to this? Okay, let's go with Samantha, Herbert. What's the answer to this?
Like the coordinates?
No, what is x equal to? Just what is x? Coordinates, you have a y. And so, yeah, okay, yeah, sure. Give me, if you want to do that, you could answer it that way too.
-1 and -5.
Correct. And Samantha said the coordinates, we could say, I like what she said there. First of all, we can say x equals -1. Okay, because if I plug in -1 plus 1 is 0. And when you multiply anything by 0, it becomes 0. And x equals -5. Now the coordinates would be -1 is my x, and what's my y? My y is 0. So -1, 0. What the heck does that mean? Then this would be -5, 0. But Sensei, I don't believe you. I don't believe that the quadratic formula can solve this. So let's solve this also using the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. You can write this down if you want, or you can just watch. I just wanted you to know that it works. I'm not asking you to take notes on this, but I just want to show you that it works. So you can use the if you want to copy, you can. I'm going to go very fast. A equals 1, B equals 6, and C equals 5. C, right? So we say x equals negative 6 plus or minus square root 6 squared minus 4, 1, 5, all over 2 times 1. So based on what I said, see, a couple things you must remember. You probably already know this, but the quadratic formula helps us solve quadratic equations as long as the equations are set equal to 0. If I'm right, then this should equal negative 1 and negative 5. So let's see. Negative 6 plus or minus square root. 6 squared is 36. 4 times 1 times 5 is minus 20 all over 2. 36 minus 20 is 4. No, 36 minus 20 is 16 all over 2. Here, let me get this. I know this. Let me hide this, get it out of the way. You guys see it? Hey, if it's unclear, let me know. Okay. If I'm like off camera, let me know, because I'm just looking at my paper. It's like a wild man here. What's the square root of 16? Let's see, I'm going to continue this over here. The square root of 16 is 4. So negative 6 plus or minus 4 all over 2. So this becomes two things. Negative 6 plus 4 all over 2. Negative 6 minus 4 all over 2. Negative 6 plus 4 is negative 2. Over 2 is negative 1. Can you see that there? Which is this right here. We got negative 1. And negative 6 minus 4 is negative 10 over 2, which is negative 5. That just happened. What just happened? I solved this in two different ways. I solved it using factoring, and I solved it using the quadratic formula. X equals negative 1 and x equals negative 5. For both of these, negative 1, negative 5. Okay. Now, after all that, are there any questions before I move on? This is very important. You need to know how to solve quadratics. Is using the... This is how you solve quadratics, is using factoring or the quadratic formula. Okay? Now, what does that mean? What the heck does negative 1, 0 mean and negative 5, 0 mean? What does that mean? Okay, let's go with, let's see. I know you guys can see. Let's go with Malia. What does that mean? If I say, let me go back here. I'll rewrite everything. X squared plus 6x plus 5. X squared plus 6x plus 5. Y equals, and I said, hey, x equals negative 1, x equals negative 5, and I had negative 1 comma 0 as my coordinates and negative 5 comma 0. Malia, what does that mean? Negative 1, 0, negative 5, 0.
Does it mean like the coordinates to the equation, or?
Okay, yeah, but what are what is these coordinates are special. What makes those coordinates special? As far, and if you need another hint, I'll give you another hint.
I don't know.
Okay, it has to do with the parabola on the graph. What part of the parabola is this?
The X and Y?
Yeah, but let's see, I'm gonna go with someone else. Yes, it is the X and Y, but specifically that X and Y. Okay. Jade, tell me what's specific about that negative 1, 0, negative 5, 0. When I graph this parabola, which I'm about to do, what part of the parabola would that be?
They are the x-intercepts.
100%. I like the way you're thinking. They are the x-intercepts. Why? Because whenever y equals 0, where is this coordinate right here? Where is negative 1, 0? Negative 1, 0 is right here. I'll do it in blue. Negative 1, and I go up 0. It's right there. Boom! That spot right there. And negative 5, 0. 1, 2, 3, 4, 5. Negative 5, 0. Wherever the vertex is, I'm not worried about that right now. I just want you to know that whenever we solve quadratics, we are really solving for the x-intercepts. Now that we know that, it should be pretty simple to figure out where the x-intercepts are. One thing we can do with this knowledge is whenever it's factored, whenever we set it equal to 0, we know that where y is 0, that's where the x-intercepts are. So that gets very interesting. What if I had something that looked like this? Y equals x plus 2 times x minus 5 times x minus 8 times x plus 4. Huh. That is pretty ugly. Make sure you write this down. I want you to graph this. We are going to graph this graph. We're going to graph it. Okay, so, Sensei, you're moving so fast. Okay, we have to go back to what we learned from before. Do you guys remember? How the heck are we going to graph this sucker? What time is it? 10:38. We're going to do our after this, we'll do our Desmos activity. Okay, how do we graph this? One thing we learned was end behavior. You guys remember end behavior? Right? End behavior. Tell me about end behavior. Let's go with Irvin. Tell me about end behavior. Everything that you know. You have to say one thing, at least one thing. You can't say, I don't know.
Could you repeat what you said again? Sorry.
Yeah, tell me about end behavior. What do you, just anything you know about end behavior. End behavior. You could probably flippy through you. Everybody flippy through your composition book. Flippy through it. End behavior. I taught it to you. Don't learn anything in this class. Do you learn anything in this class? Or do you guys even learn anything? Do you like I teach you stuff? End behavior.
It could be
Look at
infinity.
Okay. I hear what you're saying. Yeah, it's us going to infinity. Okay, you guys are flippy. I'll take that. Clara, give me end behavior. Look, you're flippy through. You guys better flippy. I'm calling you. What is end behavior? Look in your composition book. It's right there. End behavior. Anything that you know about end behavior.
I don't know. I can't find it.
It was like last week. Find something. I'll get back to you, Clara.
Okay.
Let's go with Annika. What do you know about end behavior?
If
Anything.
the exponent is odd, then they'll be opposite. So like one will go up and the other will go down.
Can you guys see me? No? Annika,
Yeah.
can you see me?
Yeah.
Odd, right?
Yeah.
End behavior is what's going on at the ends. We don't care what's going on in the middle. If it ends going up or ends going down, begins going down, ends going up, right? If it's odd, remember it's the same. If it's odd, it's different. If it's even, it's the same.
Yeah.
Even, odd, right? Thank you, Annika. Okay, what about if it's positive or negative? Okay. Alex Garcia, tell me positive or negative. What does that mean? This is positive.
If it goes up or down.
What part? Yes. Which end?
Hold on, you're cutting off. The
Positive,
the
I'll
left
just go
side.
like this. If it's positive, it means it's going to end going up this way, right? So this is going to be, let's see. So based on that information, we should be able to graph this graph here, right? So I know, here's my other question. I'm asking you guys, what are my x-intercepts here? Look at this. What are my x-intercepts? Give me an x-intercept. Ready? Here we go. X-intercepts there. You're looking at it. You're looking at it. Let's go with Ariana. Give me an x-intercept. Go. Give me an x-intercept, Ariana. X equals what? Come on, be ready. Let's go. Let's go. Ariana, give me one.
-5.
-4. We got the -4 here. Very good. Thank you, Ariana. Be ready to unmute your microphone. Get ready, guys. Let's go with Clara. Give me one.
8.
X equals +8. There's one. There's another x-intercept. Give me another one. Giselle, give me an x-intercept.
5.
X equals 5. Yes, I like it. It's quick. We're going quick. Okay, give me another x-intercept. Let's go with Kimberly. Give me an x-intercept.
-2.
-2. So we have here so on your graph, what you're going to do is you're going to go say, okay, I got one at -2. There's my x-intercept. I got one at -4. -4. There's an x-intercept. I got one at 5. 1, 2, 3, 4, 5. And I got one at 8. 6, 7, 8. Whoa, that's spread out. Okay. I also know that it's positive. So this part is going to end going up. If it's positive, it's up, right? If it was negative, you'd have a negative sign in front of there, right? There's no negative sign in front of this, so it's positive. So it's going to end this way going up in the positive direction towards infinity. Now, is this odd or even? 1, 2, 3, 4. Is that odd or even? Is that an odd or even function? Let's go with Strummer. Is that odd or even?
Even.
Even, because there's 4 of them. 4 is even. So if it's up, then the back end is going to go up. So this is going to be like this. And then you just hit your x-intercepts. Have an x. See that? So it's positive. It's even. So they're both up. And then you hit your x-intercepts. Woo! 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 And woo! And we just graphed that function. That's how you graph a polynomial function. In general, I'll let you graph that for a second, but don't ask any questions because I know what your question is going to be. Go ahead and graph that, and I'll explain your question before you ask the question. I already know what your question's going to be. Okay, so I'm going to answer your question before you ask it. Don't even ask it. Don't waste my time. Don't ask me questions I already know the answers to. Don't ask the question. Hopefully your parents can't hear me yelling at you. I'll get in trouble. I'm back to school and I'd be like, wait, I heard you yelling at my kids. Okay. I'll give you 10 seconds and I'll answer your question before you ask it. 9, 5, 4, 3, 2, 1. Here's the answer to your question. No, we don't know how far down or up to go. You just kind of guess. Okay? It's just anything. Because at this point, this is more of a calculus thing. We don't know calculus. So when we graph these polynomials, just kind of go woo, 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 woo. So you can go, you just stop wherever you stop. You just make humps. You don't end at a certain point. The vertexes are just guessed. These vertexes are guessed. Yes, you do that. I know it bugs you, but that's all we know for now. We are not in calculus. Just wait in a couple years. You'll be knocking these out when you're smarter than me. Are there any questions? Let's go to Desmos. Okay. Are we good? Okay, how do we stop presenting? Okay. Jade,
Yes.
did you learn anything new today or is it all the same? You already knew all that.
Kind of.
You didn't learn anything new? Where'd you learn that before?
Learn what?
Where did you learn all that? You knew about the x-intercepts probably already, right?
Yeah.
Okay, good, very good. So it's just kind of a refresher.
Yep.
Did you even need the refresher?
A little bit for the end behavior.
Oh, the end behavior. That's right. Okay, that's cool. Thank you. Let's see. Sienna, did you learn anything new today?
What'd you say?
Did you learn anything new today?
No.
No, okay. I didn't even do class today, I guess. I don't know. Well, here we go.
Can you see it?
We're doing Desmos. Okay. I think I go like this. Okay, I'm getting the Desmos set up here for you guys. I think I'll knock this out now that I explained that to you. I don't know, maybe not. Okay, here's your class code. So please log in. You guys know how to get to Desmos?
No, where are we supposed to go?
I'm showing you right now. Thank you for asking. I like when people just ask so I know what's going on. Okay, I'm sharing. Okay, here you go. Go to student.desmos.com and do NVDNZ3. Oh, I could go like this. Hang on. I got a better idea. Don't do that. I got a way better idea. See if this works. I know you guys can see me, stuff that I'm doing, but watch this. Click on that. I think that'll work. You see that on the I sent you something on the chat. Just click on that. Let's see. I'm gonna write that down because I'm gonna get out of this because I need to monitor what you guys are doing. So I need to. It's kind of weird. Can't see because I'm gonna stop sharing. Stop and sharing. Okay. See, you guys are in. So okay, you guys are getting in. So go ahead and start it. I think you should.
It's asking me to put the code in again, but it's not working.
NVDNZ3. Should I show it to you again?
No, I know what
No,
the
that's
code
happening
is,
to me
but
too.
it's
Me too.
not working.
Yeah, it's not giving me assignment.
Really?
Yeah.
Wait,
Yeah,
did you click on?
it just takes
you guys?
that.
Is anyone in? Has anyone been able to do the assignment?
What's the code again?
I'll put the code. Here's the code.
Okay.
See if the code works. Also, just the. Okay. I guess you need the code still. NVD NZ3. By the way, yesterday I couldn't do the remember I couldn't do the I figured out how to do the pair decks. You guys are like my first class trying all this stuff, so I figured out during third period, so maybe this will happen with Desmos. Won't be able to do this.
It's still not letting.
Yeah.
Yeah, it
It
just
It
keeps
says
asking for the code again. And
It says
It's
does not
asking
sign
what?
in.
Let's see.
it keeps like asking for the code again every time I put it in.
That's weird. Let's see. Oh, hang on a second. That would go in. Should explore the function. Huh. This wasn't what happened to me last night. Oh my goodness. I'm sorry, guys. Let's see here. Oh, okay.
it worked.
Let's see. Try. Huh?
It just worked.
Okay, I did something right. Okay, so go ahead and do that. Try it again. Try getting in again, guys. Oh, okay, I see you coming in. Okay, I just didn't assign it. Okay, so just work on that on your own. And basically what like, see, Annika already got the first one. Okay, so you could see.
Do you want us to
All right.
start the or
Yeah, just do it.
oh, when's it due by?
I just do it now. I think you
Okay.
should finish it within we're just working on it now. It's like class time. Work on it during class time.
Wait, but how are we supposed to do it if it's not letting us in?
You tried again. It's starting to I had to fix something. I made it so that you can go in now. Sienna, are you able to get in now?
I'm trying to.
Try entering the code again.
Yeah, I got in.
All right. Cool. while you guys are working on that, I should talk about cubes and squares for these. So if like I'm looking at number 5. Let's see. Like number 2 has a cube in it or a square in it, right? If it has a little bump, see if I can do it. Let's see how I can. So like if you guys are having trouble, like where'd that one go? Okay, I'm sharing. Where'd it go?
Besides, this is due today.
Yeah. Are you having trouble?
Alright.
I'm gonna tell you, it's your homework. You know, you don't have any other homework but this. This is your homework basically. Like, I guess if you want to, hang on. I'll explain. Let me just show you something here real quick. Look at, not this one. I mean, those of you who need it, like see here, right here, how it kind of touches and then goes down. It doesn't go across. Right here at this -1, you can see, right? See that at negative, when it touches like that, that's almost like a little parabola, an upside down parabola, that little section right there. It's not really a parabola, but if you think of it as one, you can say if it touches, it's almost like it's squared there. So that would be this right here would be x plus 1 squared. Wherever it goes like this, it hits a bump like this, that means it's going to be a squared. So I have that squared there at -1. That means when I plug in -1, it's going to be a square. You're going to have a little square there. We have that little bump. So like here, there's a bump right here, right? So this would also be x plus 1 squared because it doesn't intersect, just kind of bumps. The equation in the previous slide had a factor of x plus 1. What effect does the squaring that term, also called multiplicity of 2, have on the graph? Makes it cross, it makes it bounce. So I just gave you an answer. It makes it bounce off the graph, okay? So let's do this. I will leave it. I see a lot of you are like jamming through this. If you want, you can do this online with me, or you can just finish it and then you're done with your homework. You can sign off if you want and just do it on your own, or you can stay here and just hang out with me if you have any questions. Otherwise, make sure you say bye, because you know my heart. If you want to go, you can go. Make sure you say bye, because my heart will be sad if you go without saying bye. And that's that. So, all right. It's up to you. I'm going to keep looking at your guys' progress. I'm not looking at you guys, so.
For number 3, do we still have to explain, like,
Remember, there's open
our reasoning?
house.
Mr. Sanchez.
Oh, I'm losing. Wait, someone asked about number 3? I don't know who said that because my computer was freezing up.
I did.
Hold on. Madison,
Yeah.
how's your trip?
Oh, it was good. Thank you.
Happy birthday.
Thank you.
Okay, number 3. No, you just click it, right?
Okay. Because it's telling me I should explain my thinking.
Okay, well then, what is your thinking?
I'm not sure.
Well, the way I would explain it is, just so you know, like, it's because it's an x squared, x plus something squared, and this is what's really going on. And anyone else who wants to know, it's like you just have an h, and you're just shifting it left and right. So I'm going to show you what I mean by that, because I know it's hard to explain, which is what they're asking you to do, but I'm going to explain by showing you why it works. So hopefully it'll make more sense. I'm mostly concerned that you understand, not just so you know how it works for your brain so you don't mess up on it. Like if I was to graph, y equals x plus h squared. I'm sorry. Y equals x minus h squared plus k. The h is the shift left and right. The k is the shift up and down. This is the general idea that we're doing here. So you can almost say that's like the h. So if I said just this, y equals x minus 4 squared, there's no k. Remember, this shifts it to the right 2. And if I was to graph this, it would look like if I was to graph this, like it should be here. And we talked about this. 1, 2, 1, 2, 3, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. That's this here. Now the x minus 4 squared means I shift it to the right 1, 2, 3, 4. It'd be like this. And that's really what's going. It's hitting a bump. That's exactly what's here. It's the x minus 4 squared. So you can say that it's like as if you're graphing a shift to the left or right based on the h. And so if we had something like this, y equals x plus 2 times x minus 4 squared. There's my x minus 4 squared, right? See, there's my x minus 4. If I plug this into this equation and add an x plus 2 to it, the way I'd graph this, I'm just do a quick graph. I have the x-intercept of -2, x-intercept of 1, 2, 3, 4. And the way I would graph this, anytime you have a square, it's positive, it's going to end up. It's odd, so it's going to go down, so it's going to go like this. Here, now the x minus 4 squared, it's going to bump and go up like that. So it'll look like that. So, Madison, I don't expect you to do, that took me about 5 minutes to explain. Just try to do your best to explain it in 1 or 2 sentences, what I just said there. And I'm not going to mark you down for, because you can't just explain words, you have to explain it in graphs and equations and stuff.
Okay.
Did that make it worse, Madison? Or
Yeah, that made some sense.
okay.
Mr. Sanchez,
Yeah.
I was late today because I had a dentist appointment.
Oh yeah, I remember that. Okay, I forgot. Let me fix that, Urban. How is the dentist? Do you have any cavities?
Yeah, I do.
Oh, I'm sorry. Okay, anything you need, I'm recording this, so I'll have it on the. When did you get here?
I got here at 10:30.
Okay, so you probably got most of the stuff then. You're probably good, right?
Yeah.
All right. Oh, there's only 8 people here. All right, cool. Everyone left. Let's see. Whoa, 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 whoa.
I do have a question about one of the graphs.
All right. Which one?
Number 2 with the hashtag before x plus 5. I'm not sure what I'm supposed to put there.
I don't know either. What does it match up? Whatever you put? I think
there's
you
like
put anything.
should I put
Go
like
ahead.
a y there?
No, it has to be a number.
Okay.
Here, oh, no, okay. I know what it is. Madison. Look at the end of the graph going this way. What's it doing?
Going down or going up?
Going this way. What's it doing? Is it going down or up? That's what I want to know. I'm asking you.
Well, your camera's frozen, so I don't know which.
Oh, it is?
Yeah.
Oh, okay. Sorry, I was pointing. See if this works. Am I moving now? Can you see me?
Yeah, it's a little bit glitchy.
Okay.
Okay, that's better.
Going this way, what is it doing?
It's bouncing off the line.
No, at the very end. What's the end behavior? Is it going down or up at the end in the positive direction?
It's going up in the.
In a positive direction?
Yes.
Wait a minute.
Oh,
Hang on a second.
Negative?
Yeah, that's going to be a negative.
Yeah.
I'm hearing that one answer. I'm going to make sure you understand what you're saying here. Okay, you can see me presenting. This direction here, the end behavior, right here. See this?
Yeah.
See it? It's going down, right?
Mhm.
So yeah, you have to put a negative in front of there.
Okay, that makes sense.
Just put it can be a negative anything. Just put a negative. Negative 2, negative 3, but just put the negative sign.
Thank you.
You're welcome.
I just have one quick one. What's number 5? Like how?
Like, what's the answer?
No, don't give me the answer. Don't give me the answer. To help me out through it. I think I got most of it. It's just I'm missing. Oh my gosh, missing something. That's making.
What did you put? Let me write it down. What you got, Ivan?
Okay, f of x equals x plus 5 in parentheses, then x plus 1 squared, and then x minus 5.
Yeah. Wait, no, not x plus 1 squared.
No, what is it? Is it 2? No, it's not.
No. You want to be able to plug in positive 1 and make it 0.
Positive. Wait.
Be minus x minus 1.
Oh,
should be x minus 1.
It is. That's right. That's right. Okay. Yep. Got it. All right. Thank you.
You're welcome.
All right. Adios.
All right. See you, Ivan.
I'm gonna head out too. Bye, Mr. Sanchez.
Okay. All right, Madison. See you later.
I have a question, Mr. Sanchez.
What's up, Strummer?
For number 2 on the Desmos, I don't understand. Like, what am I supposed to put in there for the squared?
Oh, okay. That's what I was explaining to Madison.
Oh, were you? Oh, sorry, I was.
No, it's okay. No, I'm not saying that because you're probably. I'm gonna share the screen here. Number 2. Okay, so what?
Were you able to get the pear deck to work?
I was able to, yeah. I figured I had to fix the slides before I presented them. I had to make them special on my Google slides before I put them in the pear deck. All right, so Strummer, see right here, this little part right here?
Yeah.
See how, like, this crosses the x-axis, and this crosses the x-axis, and this crosses. So this will be x minus 2 This will be x minus 5. This will be x plus 5. Was that too fast what I said there?
No, I know exactly. No, I know what you're
Okay.
doing.
Now, this I'm going to call a bump, where it doesn't cross, it just kind of touches it. Bump. I don't know, just Desmos calls it that, so I'm going to call it that. When it's a bump at this x, at x equals -1, we write it as this right here, x plus 1 squared. Whenever it bumps like that, we put a square on it.
But when I write it like that on the thing, it shows it's wrong. Like it doesn't like match up.
Do you have x plus 5?
Negative x plus 5 times x plus 1 squared times x minus 2 times. Oh wait, hold on. There's a hold on. Wait, no.
Should be
yeah, and then x minus 5. It shows it's wrong.
Work.
Like it's not in like the right area placement.
Oh,
Try and
I see. Okay, well, okay. First of all, the main thing, remember I said it doesn't matter where these go?
Oh, yeah.
Okay, but having said that, if Desmos wants them to match up, the main thing is we got the x-intercepts good, right? See how the x-intercepts? But it looks like it needs a little stretch, so let's play around with it. Let's put a 2. Nope. See how it stretched too much? So what's between -1 and -2? Let's try -1.5. There it is. It was just a guess. I just guessed whatever that number needs to be in there, right? We start off with negative.
I thought you need to put the number where the square was on the 1. So I was like just putting all sorts of fractions.
Well, this right here, the 1 is just shows the bump. That's the x-intercept. But now that we're not getting this, how this needs to be stretched a little bit, and this needs to be stretched, we need to change the stretch factor, which is the a, which is the number in front. So I just played around. I tried -2. It stretched it too much. -1 didn't stretch it enough, so I just changed it to 1.5. I just guessed it, and there, boom, it matches.
Perfect. Okay.
What did the hint say? Try something negative. Try it. Look at the hint say. Try a fraction between 1 and 2. Anyway.
Thank you.
All right. Is that it?
Yeah, I think that's everything.
All right, man. I'll see you tomorrow.
Did we have any homework yesterday?
No.
Okay.
Just finish the test, the quiz.
Okay.
All right, man.
Thank you, Mr. Sanchez.
All right, have a good one.
You too.